This is Jun-Won Park, PhD student in Korea University. Today I will presentation about simulation of ductile fracture in aluminium plates with and without residual stresses using finite element damage analysis. Residual stress has a significant effect on failure behavior such as ductile tearing and fatigue. Therefore, quantifying the residual stress effect is an essential issue in structural integrity assessments of cracked components. Conducting experiment to analyze the residual stress is very difficult and complex. Developing a finite element damage analysis using the local approach is an efficient method. However, application of the local approach to combine the mechanical and residual stress is rare, probably because there are few experimental data clearly showing the effect of residual stresses. This experiment clearly shows the effect of residual stress on ductile tearing by systematically performing tensile CT and NT tests. In previous study, a GTM model was used to simulate this experiment, and it was possible to simulate the reduction of crack initiation load by reflecting the residual stress effect. However, it was only possible to predict crack initiation. In another previous study, the effect of residual stresses on ductile tearing resistance was numerically investigated using the GTM model. But only FA analysis results were presented without comparison with the experimental data. Ductile tearing experiment considering the effect of residual stress is simulating using finite element damage analysis were presented in this study, and the effect of residual stress on ductile tearing is analyzed. In this study, AAT test performed to analyze the residual stress effect was used. Before determining the damage model, tensile test and CT test were organized. Tests were conducted on two materials, AL5083 and AL2024. And tensile properties and gyre curves were obtained from the experiment. The minimum element size of tensile test and CT test was 0.1 millimeter and 0.5 millimeter respectively. It has long been known that there is exponential relationship between fracture strain and triaxial stress. Based on this concept, the damage model was used in which fracture strain is expressed as function of triaxial stress. The material constants A and B are determined by simulating tensile and CT test. Cumulative damage can be calculated by change in equivalent plastic strain for fracture strain. To simulate this in Abacus, usual subroutine was used to simulate local fracture by simulating stress and elastic modulus when cumulative damage reaches the critical value. This graph shows the stress triaxiality and equivalent plastic strain extracted from deepest point by simulating the tensile test. And one point representing the average value of the stress triaxiality at the fracture point can be calculated. Based on the above point, material constants that can well simulate the JR curves were determined. It can be seen that the determined damage model will simulate the experiment. Empty test was performed with and without residual stress. For AL5083, two sets of experiments were conducted with only the initial climb length being different. Here, P is the abbreviation for primary, which means the only primary stress exists and there is no residual stress. And S is an abbreviation of secondary, which means that there is a residual stress. Residual stress was generated by performing EB weldings on certain location. And maximum tensile residual stress was measured in the experiment by hole drilling method. And in addition, load according to the crack growth was measured in the experiment. Closed symbol is the case without residual stress, and open symbol is the case with residual stress. As you can see, the effect of residual stress appears only in the initial crack propagation region. AL 2024 is quarter size of the AL 5083. The specimen was divided into 3 parts, and opposite response were applied to the center and the outer tabs. And also maximum tensile residual stress and load according to crack growth were measured in the experiment. In the case of AL 2024, the effect of residual stress is significant throughout the entire crack propagation region. To simulate this in Abacus, residual stress was generated in the uncracked plate, and element remove option was used to introduce initial crack. Finally, primary load was applied. Here, the method of generating residual stress is as follows. AL 5083 uses the average value of coefficient of thermal expansion to apply thermal gradient at the weld location. And the residual stress was generated equal to the maximum tensile residual stress measured in the experiment. This graph shows the residual stress profile in the longitudinal direction from the center of the surface. It can be seen that the FE research and experiment research were in good agreement. And AL 2024 element removal option was used to divide the plate, and contrasting loads were applied to the center and outer tabs. Finally, elements were reversed. Similarly, the residual stress were generated equal to the maximum tensile residual stress. Measure. This is FE analysis model. Empty specimen was modeled as one asymmetrical model, and elastic plastic damage analysis was performed. The minimum element size was 0.5 millimeter, which is same as the minimum element size of the CT model used to determine the damage model. This is the FE analysis performed in this study was brought in as a video. As in this way, load crack propagation can be simulated from the initial crack tip. And also, load according to the crack propagation could be calculated through the damage analysis. First, here are the FE research for AL 5083. 1P1S corresponds to relatively thick crack among the two sets of AL 5083 experiments. And line is FE research, and symbol is experiment research. And FE analysis predict where the cracks initiate at smaller loads when residual stress exists. When comparing the FE and the experimental results, FE analysis predicts the experiment well. 2P2S were same AL 5083 material, but relatively shallow crack. The experiment showed less influence of residual stress than the previous results. And FE results show that these parts are well simulated and also predict the experiment well. To analyze the residual stress effect on ductile fracture, CTOD was extracted from FE analysis. CTOD was calculated by using the delta phi method suggested by ISO. The symbol represents that when delta A is 0, 2, 4, and 8 millimeter respectively. The difference in the slopes results from the difference in elastic compliance of the specimen, not from crack growth. And what is the interesting point is here is that CTOD values corresponding to crack initiation are similar for every cases, regardless of the residual stresses and crack depth, even though the slopes were different. In the case of AL 2024, there was a slight difference from the experiment. When residual stress exists, it can be seen that the load starts to increase at a point where the crack length is not zero. This is because the plastic deformation accumulated while generating the residual stress, and the crack was initiated before the primary load was applied. These results can also be found in load CTOD graph. If crack growth occurs at the same CTOD value as AL5083 cases, load CTOD curves suggest that crack growth could occur before application of the primary load. These results were quite different from the experiment. So further analysis was performed to analyze the difference using fracture mechanics analysis. The FAD was performed and initiation load was calculated according to the R6 procedure. In this presentation, only FAD results were presented. This table shows FAD results along with experiment and FA damage analysis results. For 1P1S, experiment and predicted results were all in good agreements. And 3P and 3S, FEA and FAD results were similar. In particular, FAD results also show that cracks were initiated even with very small loads. But FA results was quite different. Thus, both FE and FAD results suggest that cracking might occur during generation of residual stress before application of mechanical load. We conducted a further analysis on the fact that the initiation load was high in the experiment. First, it was assumed that a small displacement was applied when the specimen was mounted on the experimental machine to apply the primary load after generating residual stress in the experiment. According to the assumption, the step of applying a small displacement was added, and the step between the step of generating residual stress and the step of applying primary load. This figure shows the FA results according to the assumptions. Symbol is experiments and line is FA results. And 0 millimeter results is original results. It can be seen that the crack initiation load increased as the displacement increased. This is because plastic deformation occurred when a small displacement was applied and the material hardened. Based on this, there may be other causes. It seems the material hardened and the initiation load increased. In this study, FE damage analysis technique that can simulate ductile tearing considering the effect of residual stress is proposed. A multi-axial fracture strain damage model was determined using tensile and CT experiments. MT was simulated when residual stress was present, and FE analysis results were further verified through fracture mechanics analysis according to the R6 procedure. According to this procedure, it was confirmed that the effect of residual stress on ductile tearing could be simulated using this model. And data not measured in the experiment were extracted from FE analysis, and the effect of residual stress on ductile tearing was analyzed. Thank you for your attention.